Welcome to Academic Distance. So I'm giving this is 1 ohm, this is 1 ohm, then 2 ohm, 6 volts, 12 volts. So they ask me this particular question says that we should calculate the currents. We should calculate the currents in each they call this one I1, call this one I2, call this one I3. They say we should calculate the current in each of the branch. That is, calculate the current in each branch of the circuit. So find this current, find this current, find this current. To be able to do this, all I need to do is to say, let's find the nodes. So to find the nodes, node starts with a source, ends with another source. So this is the first node. This is 12 volts. So this is V1. This is node 1. So this is our I1, and this is 1 ohm. It's having 1 ohm. I1. Then for node 2, this is node 1. For node 2 will simply be everything here. Remember, they did not say current in anything, they said on each branch. So I don't have to short circuit or open circuit. So it starts with a source. So and ends with a source. Starts with a resistor, ends with a resistor. Then on this side, so this is 2 ohms. This is I3. This is 1 ohm. This is I2. This is I1, 1 ohm. Now the node 3. For node 3, you see that I have this, then to this place. So I have starting with a source which is resistor, and then ending with a voltage. So this is 6V. This is 1 ohm. This is I2 that is here. Then on the ground, this place, I see that I have voltage starting this, that is 12 volts, starting this, running like this, then to another voltage, 6V. Then inside this node, I have this. So this is node 4. Don't confuse it. Node 2. So I'm trying to make you see it. So see, this is going to be node 1, node 2, node 3, node 4. So this is the 2 ohms here. So let's label it. This is having V1 because it's node 1. V2. This is V3. Everything is V4. V4. V4 because it's in node 4. This will form our reference. The rule says we should choose one part and call the reference. I'm choosing the ground, the center part, to be like holding it. So now that I've done this, the next thing to do is to now find the current, the direction of the current. This is battery. So once you are done with this, once you are done with getting this, I normally advise my students to withdraw the full circuit. I want to withdraw the full circuit here. Withdraw the full circuit so that you don't go back and be confusing yourself with the main circuits and writing inside. Now that I have this is 6V, this is 12V. Current enters from the positive terminal. So that means this I is going like this, I2 is going like this. This is positive terminal here, up here. That means this I1 is going like this. Then this is the ground. This is ground, V4. Every node moves from node 1 will tend to move to node 2, current will tend to move from node 2 to node 3, node 3 to node 4. So to the lowest, this is the lowest potential. Current moves from highest to lowest potential. So that means that this current here is going down. So now that I've gotten this, so this is V1 here, V1. This is V2, V2. This is V3, V3. So automatically V4 is equals to 0 because it's on the ground. Now for the equations, let's now get node 1 equation. To get node 1 equation, you will notice immediately that node 1 is having voltage 1 and voltage 4. In between, you are having a voltage. I've told you, anytime you have this setup, the current is moving like this. Anytime you have this setup, always do up minus, that is highest potential minus lowest potential, equals to the middle. So V1 minus V4 equals to the middle voltage, which is, this is 0. So V1 minus 0 equals to 12. So V1 is equals to 12. Call this equation 1. And I've told you, once you get this, immediately get the super node. It will be handy. Immediately you do this, get the super node. What is the super node? Super node simply means ignoring the whole voltages here, both middle, up and down. What are the currents entering the top voltage and the lowest voltage? That is V1 and V4. So you can see very well that this current is entering. This current is entering. So just two currents. So the super node is going to be super node 1. So I always advise you to find all the equations before solving. That is, before trying to get an answer. So I have super node 1. I1 is entering node 1. I3 is entering node 2. So notice that this, node 4, sorry. This is the only current we have for node 4. And this is the only current we have. So I1 plus I3 equals to 0. And I1 is in between V2 and V1, moving from V2 to V1. So it's going to be V2 minus V1 all over. What is the resistance there? Is 1 over 1. Plus I3 is in between V2 and V4. And V4 is 0. So V2, what's the resistance there? 2 all over 2 equals to 0. So LCM is 2. So this is going to be 2 V2 minus 2 V1 2 here plus V2 all equals to these 2 come and times here. This 2 that is SN times 0 is equals to 0. So this is super node SN equation 1. Super node equation 1. It's not a node equation, it's a super node equation. So super node equation 1. So let's move to node 2. From node 2, which will give us the second equation. Remember, I once told you that anytime you have 4 nodes, you should have 3 equations. So note it. Don't go and use super node equation and don't mix super node and node equation. It's always going to be node equation to node equation, super node equation to super node equation. Once you mix this up, you will fail that particular question. Super node equation to super node equation, node equation to node equation. If you do any mathematics and mix it up, you will fail this, you will make mistake. So node 2 now is simply go to node 2. This is it. What are the currents entering? Remember, this current is leaving. Come here, this is it. I1 is leaving. I3 as I2, sorry, I2 is leaving. I3 is also leaving. Because note, this is the node 2 now. So this one is going to node 1. This one is going to node 3. This one is going to node 4. So all the currents are leaving. So that means node 2 is simply minus I1 minus I2 minus I3 equals to 0. So since everything is minus, I can choose to say let this be multiplied by minus 1. So everything becomes plus. So this is something that's saying I1 plus I2 plus I3 equals to 0. Do it well. I1, we've already gotten it to be V2 minus V1. Is in between V2 and V1. The resistance there is 1 plus, this is V2 over 2 plus I3. Let's check I3. I3 is in between V2 and V4 now, Shebe. Are you? Yes. Yes. Wait. Yes, I3 is between I3. This is I3 between V2 and V4. So V2 minus V4, and V4 is 0. So V2 over the 2 that is here. What am I doing? So I2 is actually, this is I2 is actually between V2 and V3. V2 and V3. I2 is between V2 and V3. So V2 minus V3. V2 minus V3. And the resistance there is 1 ohm. So it's supposed to be 1. So all over everything equals to 0. So all over this. So if you do it very well, you have 2 here, 2V2 minus 2V1, then plus, this is over 1, plus 2V2 minus 2V3, so 2 here plus V2 equals to 0. So if you put this together, this is V2, V2, V2. So 5 V2. This is V1, 2V1. So minus 2V1 minus 2V3 equals to 0. Okay, well, we know that somewhere along the line we got that V1 is equals to 12. V1 is equals to 12. Then V3, we can get V3, but let's move to now. So let's call this now equation 2. We've gotten that is the node equation, n equation 1, n equation 2. So now let's go to node 3. When you learn this properly, that's when you start jumping steps. Now that you are still learning, follow it the way I'm doing it. So node, then that is for node 3. For node 3 equation, that's the last equation, because node 4 already has voltage which is equals to 0. That's why we always have 3 equations for 4 nodes. So node 3 now will simply be, this is V3. Notice V3 is having voltage up and voltage down, and in between is having a middle voltage. So just do, and the movement is this way. So just do V3 minus V4 equals to the in between, which is 6V. So minus 0. So V3 is equals to 6V. So this is the third node equation. This is the third node equation. I can as well say, as I've gotten this, there's no use for this, but I'm teaching you, that's why I'm putting out everything. I can as well say, because we can have a complex case, say let's find the super node here. Notice that everything here, if I silence the up voltage, the middle and the fourth one, what are the currents entering the up voltage, which is V3, and what currents are entering the lower voltage? Which currents are leaving? Which currents do you have leaving the up and the lower voltage as well? So the super node equation, which is the second super node equation, so super node equation 2 will simply be, go back here, for V3 is easy here. V3 has I2 entering it, so it has I2 entering, that is I2 entering. Then V4 has what's I is this I3. V4 has I3 entering it, so plus I3. So if you go back here to the main circuit, you see it. This is I2 entering this V3 node. This is I3 entering this V4. So all equals to 0. So you can as well do I2 is in between V2 and V3. All over the resistance there is 1, plus I3 is in between V2 and V4. But V4 is 0. So just V2, the resistance there is 2, goes to 0 over 2. So this is going to be 2V2 minus 2V3 plus V2 equals to 0. So this is something that's saying 3V2 minus 2V3 equals to 0. So this is the SN equation 2, supernode equation 2. If I want, I can combine these two, but I just want to come here and simply say, go to the node equation. Node 2 has just node, not supernode. So to find V2 here, I can just say from equation 2. So from equation 2, which is 5v2, so let these things now cross equality sign, equals to 2v1 plus 2v3. So you can see that this is the same thing as saying v2 equals to v1 already is 12. So 12 plus 2. Now v3 is what? 6 all over this 5. So v2 will be equals to 24 plus 12. 24 plus 12 all over 5. So v2 is equals to 36 over 5, which is equals to 7.2 voltage. That is v2 for you. So now that you've gotten v2, it's now easy for us to say we've gotten v1 to be equals to 12, v2 to be equals to 7.2 volts, v3 to be equals to 6 volts. One common mistake some students might make is that when they got this super node 1, you might be in a hurry because you already know too much. You say, since I have v1 as 12, let me use this to find v2. It will give you an answer close, but you find that you get like 8, so it will be a bit higher. So that is why I normally advise my students, check the node that thing falls into. If I have to get v2 here, I have to put it together with the second super node in order to solve anything. So I always advise my students, if it's in a node that doesn't have super node, make sure you are using the node to solve for it. So now we progress. We now see that we can now come here and say I1 is what? From this I1, from this our setup, I1 is in between V2 and V1. So V2 minus V1 all over 1 is I1. So V2 minus V1 all over 1 is I1. So I1 is equals to 7.2 minus 12 all over 1 equals to 7.2 minus 12 is equals to what? Minus 4.8 over 1 is 4 minus 1. So I1 is equals to this in ampere. So this is as good as saying I1 approximately or is equals to 5 ampere, because the negative sign doesn't matter when it's current or voltage. So now for I2 is going to be in between what? V3 and V2, and is moving this way, so it's moving from V2 to V3. So it's going to be V2 minus V3 all over what current, what resistance is there? Is 1. Look at it, I2, V2 to V3 all over the resistance there, all over 1. So I will do equals to V2 is 7.2 minus 6, I3 is 6. Sorry, V3 is 6 all over 1. So I2 is going to be 1.6. So 7.2 minus 6, 1.2 volts. Now for I3, is in between, watch this, it's in between V2 and V4, and V4 is 0. V4 is 0, so it's just V2. And the resistance there is 2, so V2 over 2. So V2 over 2. So that you have 7.2 over 2 for I3. So I3 7.2 divided by 2 equals to 3.6 ampere. So this is how you go about this. This is how you go about it. So the answer is for I3 is 3.6, I2 is 1.2, and I1 is 5 ampere. Remember I said, always find your equations out, all the equations, find everything out. When you finish finding all the equation, if you have need to put super node, let it be super node against super node. Then if you have reason to put the node, let it be node against node. Don't ever use node inside supernode or use supernode inside node. It will make you get a wrong answer. Thank you.